All right, so for the next one, 4.1, number 48 here. Um, so they give us a function f of x, and they give us an interval that it's on the interval 2, 6. And I'm looking at the directions here real quick. Find the critical points of f on the given interval. Determine the absolute extreme values of f on the given interval. Use a graphing utility to confirm your calculations. All right. So we'll start off by determining if there's a critical point or how many critical points or where the critical points are. So we do that the same way we've been doing that. We're gonna take f prime of x. So in this case, well, what are we really saying here? We're saying that this whole thing to the 1/2 actually could be rewritten up here, f of x, as not that we want to see it this way, but as x minus the square root of x minus 2. So we kind of know what to do with this. We would rewrite that as this. So f prime of x would be 1/2 times x minus 2 to the negative 1/2. Okay? And we should rewrite this real quick because this is not the best way to write this out. This really becomes 1 over 2 square root of x minus 2. So that's my derivative. What I would do then is I would take that derivative, and right here I'm going to set it equal to 0. So I need to ask myself, what can I plug in to x to get 0? Well, I could put a 2 in here. 2 minus 2 is 0. Square root of 0 is 0 times 2 is 0. I get 1 over 0. That's not allowed though. So in actuality, this particular problem, this can never be 0. So this is kind of a strange one. So that means that it doesn't mean, it means there's no critical point per se from that standpoint. So we would say maybe no critical points. However, if you remember back from section 4.1, extreme values are at one of 3 locations. They're either at a critical point or they're at the endpoints. So in this case, 2 and 6. So what I would do is maybe try it for f of 2. So f of 2 equals, and I can rewrite that whole thing again as we did before, the square root of 2 minus 2, that's the same as saying x minus 2 to the 1/2, which equals the square root of 0, which equals 0. Okay, that's one example. And f of 6 is my other endpoint, which equals the square root of 6 minus 2, which equals the square root of 4, which equals a 2. So these are going to represent, in this case, it's pretty actually easy to tell. This is small, and considering you are either at a critical point, which we have none, or you're at an endpoint, well, since this one is the smallest, this one's going to be an absolute minimum. And since this one's the largest, this one's going to be an absolute maximum. And we know there is no thing bigger or smaller than this because of the fact that there is no critical point. If there's a critical point, we would also check that for an absolute minimum or maximum. But in this case, there isn't. So the last step would be to use Desmos or a graphing utility of some sort to figure out what this graph looks like and kind of confirm your answers. So here's x, here's y, and when I graph this one, let's go 2, 4, and 6. When I graphed this one, I got something that looked a lot like this. And so you can see at the end point, 6, and at the end point 2. So I was at 0 here, and I would be up at, I guess this would be 2 here. Oh, excuse me. Yeah, Yeah, that's right. So f of 6 equals 2. So this all looks great. So this just confirms, based upon the graph that I got out of Desmos, that this indeed was an absolute maximum, and this indeed was an absolute minimum.